Hi, everybody, and welcome to another Fika AI. I'm ABK of Neo4j, and I'm here with my friend Liz. Liz, good morning.
Hi, good morning.
Good to meet you. Good to see you. We've just met this morning, and we're here at JFocus. And my friend Liz, introduce yourself. Who do you work for, and what do you do?
I'm Lize Raes. I'm developer advocate at Oracle, and I focus on Java and AI.
Oh, which is fantastic. We're here at the Java conference. This, as all conferences, they've turned into a bit of an AI conference. And like at Oracle, what's the thing that you're focusing on?
Basically, making clear that Java already supports a lot of AI inside both the platform and the ecosystem, because people are not always aware. It's still the thought that you can only do these things in Python. But actually, we have both in the ecosystem for LLM inference and agentic. We have a bunch of great stuff, like J4j, where I'm myself also a collaborator of the project, Spring AI and Babel that we have on that side. And then on the machine learning side, with Project Babylon that's growing inside the Java architect team, we also get to do very interesting things with GPU already now.
So I want to get into that. That sounds fantastic. I will comment that it feels to me, if I can hear we're at the, wait, not January anymore, now it's February. It has been in Python for so long, people doing it in AI, and it makes sense, that's where the kind of community started. But this feels like the year that all the other languages will suddenly catch up. That's not work just happening in Python. What's happening in Python isn't really so much about just making models anymore. It's about using the models. And you can do that in any language, right?
Yeah, that's, yes.
Doesn't matter quite as much. But then you've got this particular angle on this, which is with this Babylon framework. Is it Babylon AI, or what's the?
No, so Babylon framework or Babylon project, it's one of these big projects that in the Java development. It's experimental for now, so that has to be said. It's not production grade ready yet, but it's all about translating programming models. So it's not just about AI, it's also, for example, you could write Java code that is like SQL adjacent, and Project Babylon will turn it a level lower into some intermediate representation from where you can go to, say, SQL, AutoDiv, AI models, actually any model you want, including the AI models, exactly.
Yeah. So that sounds fantastic. And now the name makes sense. So the Babylon, like, the Tower of Babel, many languages that are spoken, and translating. And I'm going to assume here that this is actually a rule-based, reliable translation, so that if you do it once, it'll translate that way again. It's not the probable, but maybe not always correct translation that LLMs get, right?
It's not that they put an LLM in the middle to do some hopefully good. No. Yeah, it's definitely deterministic.
This is deterministically done.
But also, I mean, it needs to be actively done for each programming model you want to branch out to. So yeah, we support a number of them already. I know, like me and my colleague Anna Maria at Oracle, we are working also to cover PyTorch. We already have Onyx, which is like open neural network exchange standards for saving machine learning models. That one's already in there, so you can actually already write your own Onyx model in Java code, and then Project Babylon takes care of translating that and running that on your GPU.
Then I'm going to take back what I said earlier, because it's not just that in Java language these days, you can now access and do like Lang4j type stuff, like in Java with Spring AI. You're going well past that. Like some of the ML stuff, you want to do that in Java? Go for it.
Yeah. I mean, it must be said, like, we shouldn't be bashing all these other programming languages. Like, each programming language has their own strengths, and in Python, it's very much experimenting, and with their Python notebooks, it's like in research very well established for good reason. But then the moment you're taking things to production, as usual, it's a bit harder in Python, and then there's Java's strengths shine, versioning, maintainability, scalability, all these things that you have already in Java. So yeah, for these mature enterprise projects, definitely, I would say go to Java. AI is possible there too.
But I love this. Like, as an AI engineer, like, that's the term that people have on their LinkedIn's now, that they maybe used to be a full stack engineer, and now people are AI engineers and kind of transitioned over. Right?
Well, on LinkedIn, even my dog would be an AI specialist.
I want to meet your dog. I've got some questions. I've got questions. But so being able to do all of this in actually, I would think through Babylon in your language of choice, figure out where you want to do things. That sounds amazing to me. And you're right, like different languages have different strengths. As an AI engineer, one of the things you quickly realize is that when you're building an agent, let's say an agentic system, multi-agent maybe, you spend so much time just messing with the prompts.
Yeah.
You're not doing the software part of it.
Yeah.
The software part is kind of bundled down into the tools. And actually, for enterprises, exactly at that point, those tools have to talk to the rest of the enterprise.
Yeah.
And for many enterprises, that is still Java,
Yes.
right?
That too.
And so this entire connection is like, well, if most of the work is messing with your prompts and giving them access to tools that should talk to your enterprise, while Python is fantastic, there's less of that available in Python. So on the tool side, for sure, like Java seems like a great environment to be in.
Yeah,
I think that's
exactly.
fair? Yeah.
Yes. And especially when we're talking about agentic and reaching out to LLMs, there's not really a reason that Python would be better than Java. And then on the contrary, like for enterprise stability, you want versioning of your prompts, you want actually test results. So like non-deterministic testing exists, and Java is just very good with the testing frameworks already. So you want to, fix your model snapshot, because if you don't specify your full model name, then it's just going to change behind your back. And the prompt that you made work for one model will just all of a sudden do something else.
Yeah.
So these things, like, they're super important when you go for like enterprise level solutions and you want to have versions of your model, of your prompts, of your test results, so you can, things just don't change behind your back. Exactly.
That makes a ton of sense. Like, and exactly as you're saying, like having the very specific model that does this very specific thing is so important. I'm sure everyone who's done anything with like any kind of a co-pilot and maybe use Claude and they're like, oh, I'm going to try out Kimi K2.5 is cool now, so let me try Kimi 2. And people talk about like the vibes of the models, like that they feel different. And that's fine when you're just kind of doing co-pilot, generating code. Okay, you know how to talk to Claude versus Kimi versus something else.
Yes.
You learn how to speak with them.
Yeah.
That's fine when you're directly interacting. If you're doing that in an automated workflow, you don't want to vibe your way through the workflow. You'd be like, okay, this model works exactly the way I want it to. Pin that down.
Exactly.
Have evals exactly for that one. All those kinds of things, right?
Remember when this first Sonnet version came out from Cloud, and you would have to say like, yes, do it. Like, shall I do this test? Like, yes, again, yes.
Let's try.
And then it changed to this next version of Sonnet that just want to do everything, change your whole code base without you even like said it should do something.
Yeah.
And that's what's happening also in your actually production code, right? If you don't pin this model version.
Oh my gosh, just imagine the mayhem.
Yes. I mean, and then let's start talking about the security aspect. So yes, you give it all these tools that have access to your business process and can do actually real changes. So you want like a human in the loop final validation before you do anything critical. And you want guardrails and constraints on everything that's going to happen in there. And also, therefore, like Java is excellent.
Because there's such a rich history and a rich ecosystem for supporting all of those things. Exactly.
Exactly.
Right? Yeah. Huge advantage for the Java community in that regard, for sure. And so I have to ask, of course, we're here at JFocus. Did we just have your talk?
Yeah.
Is this what your talk was about?
Yeah, well, no, my talk was about Project Babylon only.
Oh, just the Babylon part. Okay.
Yes. I also very often talk about agentic and like Jane4j because that's the shop I come from.
Right.
But it was about Project Babylon. So not only how to define this machine learning models with Onyx for now in Java and get them to actually run on our Mac unified memory, but also there's a part of Project Babylon in their HAT, Heterogeneous Accelerator Toolkit. It's a mouthful to say basically allow parallel programming paradigm in Java. It looks like a bit special, but still very much Java. And then you can talk directly to any type of GPU.
And is this like a DSL for doing it? Or like what does it actually manifest as in the language?
They have constructs to reach out to native memory segments and kernels. So basically you have three types. Your normal Java code that sets up which GPU you want to talk to and prepares the calling. Then you have compute code that's in the middle that's going to do dispatching. It's still like the JVM, but dispatching it to GPU. And then there's a kernel code that's actually code that's only going to run on the GPU in these kernels in parallel. You're very limited in what you're allowed to write in there because these GPU kernels aren't very strong and they don't have all the context. But you have like your memory segment and you can do mathematical operations in this small kernel code. And that's kind of how it works.
Okay.
So like
3-layer
JVM,
system.
dispatching, and then what's actually run on your GPU.
Okay.
All
okay.
written in Java.
All in Java. Okay.
Yeah.
That sounds amazing. And like, is there a great kind of like hello world? What is the hello world, I guess, for this? What's the smallest useful thing?
Makes sense to ask that. Like we show squaring all elements of an array, because you can do that in parallel. Like the next item of your array doesn't depend on the outcome of the first. So you just like have
Right.
an array of 1,000 items, and then you have that squared 1,000 times in parallel instead of sequential as we usually do it in Java. So that gives you order of magnitude 1,000 times speed up for the specific problems that parallel computing makes sense for, right?
So then would you recommend, like, for general Java developers, whenever you're going through, you're doing your profiling of your code, and you hit that one function, it's like, okay, this all the time is spent here.
Instead of this
is when you
loop, just
pull
do it
this
all in
tool.
parallel.
Okay.
Yeah, exactly. Yeah, I mean, it's still experimental, right? So don't build your final software on it yet, but it's definitely going to come. And yeah, I would say, I actually hope that the ecosystem steps up with this and says, for all typical algorithms where parallelism makes sense, we make a hat parallel implementation of them too. And then our developers can just use the libraries, right? And they just like,
Oh, yeah.
you call it parallel loop or whatever would make sense.
So is there like a community effort to like build a collection of
We hope
solutions?
that will come. At
Okay.
the moment, not yet, because it's still very, very experimental. So at the
But you
moment,
could see that on the
I
horizon.
see the potential.
Yeah.
Yeah. I'm
Okay.
also like, now we have it. I'm like, oh, how could we do without? Like, you know,
Yeah.
being forced to do everything in serial, even if it makes a lot of sense to parallelize here and there, always. Yeah. It's also with this GPU getting built in every laptop at these days that this becomes actually possible to
Right.
do on your machine.
Assuming the
It's exciting
supply
times.
continues and like GPUs are not taken away from us.
That they're going to take them out of our computers to put them in the data centers. Yeah, no, for sure.
Okay, that's awesome. So I love this. I'm gonna have to learn a little bit more about this. I'm not the most expert Java developer, but I switch between languages all the time. So actually,
Cool.
every aspect of this really appeals to me. Like when I swap over from having done some code in Python, it's like, oh, let me try this in the Java. I'm doing things with Spring AI these days. I'm definitely
cool.
gonna check this out and see how this all kind of plays together.
Nice.
This sounds really nice. I'm now gonna ask you a bit broader view. Again, we're here at JFocus. What's your sense of like the Java community right now and where things are headed for Java? Do you have a gut instinct like is this the year of Java and AI, or is there something else that's a bigger trend beyond that?
It's a good
obviously the
question.
things you're doing?
Yeah. Yeah, I think it's still a mix of skepticism about AI and keep doing what we are good at. I must say it's insecure times. Everything changes super fast, also for Java developers.
Yeah.
Yeah, it's incredible. Like I think nobody can look further than 2-3 years ahead. I do have the impression that our roles will be more going towards integrated product management when like code creation becomes more easy, faster with our junior pair programmers, and you see companies and developers sitting at very different speeds there. So I saw a post on LinkedIn of somebody from Airbnb that said like AI is writing 90% of my production code. If it's not doing that for you, you're doing something wrong. And I'm like, yeah, I can like see why that is. But then you have these big Java companies that work in regulated environments where there's like out of the question to send your code and your IP to any external model whatsoever. They're not allowed to use AI assistants at all yet. So we're like, yeah, interesting times.
A lot's going to change, and we're not sure where all that's going to be headed. One aspect that I'll bring back actually to Babel, like as more code is being generated, in my own projects I've found, because I switch between languages all the time, if I'm in a functional programming mood, and let's say I'm doing something in Python, I find it very hard to convince any of the models to generate good functional code in Python.
Yes.
And there's reasons for that, because it's not the most amenable language for that.
Yeah.
And so I've found for my own project sometimes that I will switch to Haskell, do some prototyping in Haskell and say, great, now that you've helped me with this, now port it back to Python.
Yeah,
And
exactly.
now I would turn to Babel and be like, oh, great. I'm just going to have this be an automated translation back. I don't know if Haskell's in your wheelhouse yet, but
Yeah, like spoiler there. I don't think the models are trained very much on Babylon yet. So
oh, no. Okay.
yeah. But like it's like becomes part of our job now too, to generate enough content so the models can actually pick
So
it
they can
up.
do it.
Like it's the same for modern Java, right?
for sure.
We at Java Platform Group, we would love these models to spit out latest version of modern Java, but there's more training material from earlier. So like it's one of the things we're also working on to provide the data sets that this is modern Java that it spits out.
Yeah.
It's
Many possibilities in the future. It all looks, for the moment, the fast pace is frightening, but also kind of fun.
yeah, it's wild.
It's
Say it
wild.
like that.
It's wild.
Yes.
Thank you so much for spending some time chatting with me this morning. This has been really good.
Thank you very much.
Thank you, everybody. We'll see you next time.